The forest held its breath and then conspired with steel. October 7th, 1944 began like a whisper in the damp morning woods northeast of Aachen, Germany. A line of trees and mist, and the small human calculations that decide life or death. And Sergeant First Class Herbert Goldberg peered through the periscope of his freshly delivered M36 Jackson with the same nervous clarity a hunter feels when quarry steps into the clearing. The massive 90mm barrel jutted from the turret like an accusation, an instrument not of poetry, but of sudden, uncompromising consequence. And at barely 600 yards through the autumn haze, 3 silhouettes detaching from the tree line made the world compress into a handful of seconds. Panthers. Machines that had taught Allied tank crews bitter lessons since Normandy. German gunners who had learned to treat the 75mm Sherman as a paper target, and who now, perhaps complacent, traversed their turrets toward what they assumed was another underarmed American vehicle. What those Panther commanders could not know, what German intelligence had failed to appreciate, was that Goldberg's Jackson carried a weapon born from a different problem set entirely. A gun designed to hurl projectiles skyward at 40,000 feet, that had been adapted in wartime Washington into a mobile, brutal counter to increasing German armor. And in 17 seconds, when Goldberg's gunner pressed the firing pedal, the crew of that lead Panther would learn, in the most absolute terms, what American industrial capacity and rapid adaptation could accomplish when doctrine, engineering, and urgency collided. If you watch these moments and feel the hair on your neck rise, you're touching on the human core of armored warfare. The same bureaucracies that delay and debate can also, given pressure and purpose, produce solutions that change the psychology on a battlefield. The story of how a 90mm anti-aircraft piece became the salvation of American armor doctrine does not begin in the mud and smoke of the Ardennes, but in the sterile offices of the United States Ordnance Department in late summer 1942, where men faced a problem that threatened to make a generation of armored doctrine obsolete, where intelligence from North Africa and the Eastern Front delivered a cold arithmetic. German armor was moving faster than Allied weapons development, and the new M10 tank destroyer's 3-inch M7 gun, deemed adequate in design rooms, could only defeat roughly 90mm of armor at 500 yards under ideal conditions, a figure that evaporated in the face of German frontal plate engineering, which, through sloping and thickness, produced effective defenses well in excess of that figure, meaning an American tank destroyer would have to close to suicidal distances into lethal zones to get a kill. This was no mere tactical inconvenience. It was a potential catastrophe that risked thousands of lives and the very credibility of mobile armored operations. The odd solution, cruelly elegant, lay in American anti-aircraft arsenals. The 90mm AA gun, developed through the 1930s to strip the sky of high-flying bombers, packed muzzle velocities and propellant charges that hurled a 24-pound shell at speeds above 2,800 feet per second. Performance that in theory could tear through armor if the gun could be adapted from static emplacements to a mobile carriage, and if engineers could solve a stacked set of practical problems: recoil, balance, protection, and accurate sighting from a moving, relatively lightly armored platform. The first attempt, rushed in August 1942, was the T-53, a 90mm shoved into an open mount on an M4 Sherman chassis. Optimism outrunning engineering, and the result was predictable and brutal. Recoil overwhelmed suspension. The crew had no overhead protection, and the vehicle's center of gravity made stable firing nearly impossible. Tank Destroyer Command under General Leslie McNair rightly objected, and the contract for 500 vehicles was quietly cancelled before a single rushed prototype saw combat. The ordnance men went back to the drawing board, and by October 1942 they tested a refined 90mm T7, a ground-adapted evolution of the M1AA gun, in an M10 turret. But the M10's light turret could not manage the weight and recoil. A new turret was needed, and fast. What followed was engineering under pressure. A new turret design created through late 1942 and early 1943 that incorporated power traverse, so the gunner could slew the massive weapon electrically rather than by hand. A massive counterweight to balance the long barrel. A single large casting for the turret walls to provide structural integrity while simplifying production. And rounded surfaces that marginally improved ballistic characteristics, while shaving complexity from the manufacturing process. The prototype, designated the T-71 gun motor carriage, emerged in March 1943. And when tested at Aberdeen Proving Ground, it did not simply meet expectations, it exceeded them. The tank-mounted 90mm M3 gun could penetrate 129mm of armor angled at 30 degrees at 500 yards, and retained 122mm of penetration at 1,000 yards. Numbers that meant, for the first time since Normandy's hedgerows had shown Allied crews the raw limits of their armament, American crews could contemplate defeating Panther frontal armor at realistic combat ranges, and could engage Tigers at standoff distances previously thought optimistic. Accuracy data reinforced the narrative. Average dispersion figures between 500 and 2,000 yards were remarkably tight for such a large weapon. And when compared to Britain's vaunted 17-pounder, the M3's dispersion numbers suggested American crews, properly trained, could reliably engage targets at ranges that would make German commanders uncomfortable. But testing and doctrine live in different houses. Bureaucracy and production logistics meant the T-71 spent months as a promising prototype, while frontline units continued to buy time with bravery and improvisation. Ordnance officials fretted about redirecting 90mm production already strained to support anti-aircraft needs and the nascent requirements of future tanks, while General Dwight Eisenhower and field commanders grew impatient as Panthers proliferated in Normandy and beyond. The transformation from promising prototype to standardized weapon came on June 1, 1944. When the T-71 was standardized as the 90mm gun motor carriage M36, and production commenced, slower than desired, yet urgent in consequence. The M36 required the M10A1 chassis based on the Sherman M4A2's drivetrain. But bottlenecks forced pragmatic adaptation. The M36B1 would mount the turret onto M4A3 Sherman hulls. The M36B2 would use standard M10 hulls with diesel power where needed. And this flexibility in production, though messy for logistics, revealed a core American advantage: industrial elasticity under pressure that German industry, increasingly starved by strategic bombing and resource shortages, could not match. The first M36s reached Europe in early September 1944, and they were sent where the need was most desperate. Tank destroyer battalions who had been fighting German heavy armor with what felt like paper tools. Crews adopted the new machines with a mix of relief and frustration. The 90mm rounds were heavy and bulky, slowing loaders accustomed to lighter 3-inch shells. Gunners adapted to a weapon whose recoil and muzzle blast were unmistakable and sometimes blinding in the open-topped turret. Commanders worried about limited stowage. 47 rounds in total, with 11 tucked in the turret counterweight, and the rest in hull sponsons. Yet all recognized the blunt, visceral advantage the gun offered. The M3 gun could fire multiple ammunition types tailored to battlefield needs. The M82 armor-piercing capped round carried an explosive filler designed to increase post-penetration effect and was devastating against ammunition racks and internal volumes. The M71 HE round provided utility against fortifications and soft targets. The M34 HVAP with tungsten carbide cores could deliver absurd penetration, up to 221 millimeters at 500 yards. But tungsten's scarcity relegated this most promising round to relative rarity, a frustrating caveat in an otherwise revolutionary platform. The empirical moment of validation came on October 7, 1944, in those woods near Aachen. The geometry favored neither side. 600 yards put both weapons well within lethal envelopes, and Goldberg's crew, with a gunner named Corporal James Bates, who had only 3 days of rushed qualification on the system, found their training suddenly meaningful. Bates centered his reticle on the Panther's gun mantlet, the one place where armor was vertical and comparatively thicker rather than cleverly sloped, and fired. The recoil rocked the Jackson, the muzzle blast shrouded the sight, and then the smoke cleared to reveal the lead Panther burning, its turret blown off by an internal detonation when the round breached the mantlet and reached ammunition stored behind the breech. The second Panther tried to react. Bates's power traverse let him track faster than German manual traverse could respond. Goldberg ordered a 20-yard displacement to change angle while maintaining hull-down protection, and another round found the turret face and produced yet another catastrophic internal explosion. The third Panther, confronted now with a weapon it could not defeat from a frontal approach, withdrew into the woods. The field report was almost antiseptic. 3 engaged, 2 destroyed, 1 withdrew. Ammunition expended, 2 rounds. Engagement time approximately 45 seconds. But the consequence rippled further than the terse words could express. Where Panthers had once advanced with confident contempt for Allied guns, word of the M36 spread like a cold rumor. American forces now possessed a tool that could rewrite assumptions about frontal engagement ranges. The psychological effect on German armor operations was as real and as lethal as physical penetration. Commanders who had relied on frontal superiority at ranges beyond 1,000 meters suddenly found themselves cautious, unwilling to close in without recon and supporting infantry. And this erosion of aggressive momentum cost the Wehrmacht dearly in a campaign that depended on tempo. The M36 did not make American armor invulnerable. Its weaknesses were stark. Thin armor and an open top left crews exposed to shrapnel, airbursts, small arms, and flanking shots. The vehicle's defensive envelope was fragile, if not exploited correctly. Ammunition shortages, particularly of HVAP rounds, limited the system's ability to defeat the heaviest targets frontally, and commanders had to accept trade-offs. A platform that traded protection for firepower and relative mobility in exchange for the ability to punch through what had until then been near impervious German frontal armor. Yet in combined arms, where artillery, air, infantry, and engineering units complemented one another, the M36 found its lethal niche. When Allied forces landed in June 1944 and were surprised by Panthers in Normandy, by mid-June nearly 40% of German tanks in some sectors were Panthers, not a trickle as intelligence had predicted. The failure of American 75mm Shermans and even hurriedly upgunned 76mm variants to reliably defeat angled Panther fronts became a brutal lesson, one that propelled the T-71 from shelved prototype to top priority. By the Ardennes in December, M36s were scarce but invaluable. Manufacturers had delivered roughly 1,000 by October, and a few hundred more in November. But by December 20th, only about 236 were in the field, leaving tank destroyer battalions to receive piecemeal allocations that made each M36 disproportionately important. The M36's legacy influenced post-war priorities. The Pershing heavy tank, rushed into service in 1945, would mount the same 90mm gun in a fully armored enclosure, a tacit acknowledgement that firepower and protection must be married, rather than offered as alternate paths. Subsequent American main battle tanks, the M46 M47, M48 and beyond, would reflect this hard lesson, that gun mattered as much as armor, and that industrial agility could tilt strategic balance. In the end, the supreme irony of the M36 story is its reminder that victory in modern war rarely rests on a single brilliant weapon alone. It depends on the messy, terrifying alchemy of engineers and assembly lines, of doctrine that accepts trade-offs, of crews willing to trust unproven tools under fire, and of commanders who can integrate disparate assets into a coherent whole. For German tank crews in late 1944, the Jackson was not merely another Allied vehicle. It was a psychological rupture, a weapon that punctured the assumption of impunity once enjoyed by thick glacis and sloped plates, and that forced tactics to change, momentum to ebb, and a faltering offensive to bleed time into defeat. Sergeant Goldberg's day in the woods northeast of Aachen ended with a report to battalion headquarters. 2 Panthers destroyed, 1 withdrawn, ammunition expended, time engaged minimal. On paper it was concise, almost clinical. But between those terse lines lay the larger truth. A rushed ordnance innovation, honed by engineers who had read intelligence and recalculated risk, welded into chassis by factory workers, maintained by grease and grit and mundane courage, and fired by men who had learned to rely on a system they barely had time to master. That composite of human and machine reshaped armored warfare on the Western Front. The lesson the M36 left behind has an antiseptic clarity for military planners and a quieter moral for students of history. Superior engineering solves problems, but it must be married to production, doctrine, and the will to adapt, or else brilliance sits idle. Conversely, industrial capacity married to pragmatic design and courageous crews can, in months, undo the tactical advantages painstakingly engineered by an adversary over years. If this deep dive into the M36's sudden birth and bloody baptism hooked you, tell us below which single innovation you think most decisively changed the course of the Second World War. Drop your country in the comments so we can map where our viewers are watching from. And if you want more cinematic breakdowns that trace technology into tactics and tactics into human stories, subscribe and ring the bell. There are more forgotten turning points waiting to be unearthed, and their lessons applied to how we think about power, industry, and the terrible arithmetic of conflict.